everyone. Today we will start module 3 Vapour power cycles. So Vapour, already we have studied two modules. One is air standard cycles and IC engine and gas power cycles. All three modules we have aimed at generating energy with the different options. Like air standard, we have studied air as a media and we have calculated the efficiency and generating power options we have seen there. In IC engine, we have burned petrol, diesel and these fuels in the internal combustion engine and generated the power. In gas turbine cycles, what we have done? We have used the gas, we have passed through the compressor, then passed to the combustion chamber. In the combustion chamber, we have added energy, then that energy, added energy which is used in the turbine to rotate the turbine blades and generate the energy through the generator. So now we have another option is vapor as a media to generate the power. How vapor is generated now? We have water. When we heat the water, vapor is converted. Still more, if you heat, you can get the steam. What is the difference between vapor and steam? Vapor means it has some particles of water in that. Still there are some particles of water in the media. That is called as vapor. And what is called as steam? Steam is, there are two types of steam again. One is dry steam and superheated steam. Right. So dry steam means 100% dry. It doesn't have any single particle of water particle. So it is a purely in the gaseous state. We believe that dry steam is as good as a perfect gas which obeys all the perfect gas laws. Later, still we are having some option to add the energy to the dry steam. So whatever you heat this dry steam, that will be converted into superheated steam, which is much higher than the dry heated steam in terms of temperature and in terms of energy also. So that steam again it is used for the generation of power. Right. So now we'll see the cycle. Whatever he said, vapor power cycle. So cycle means what? Again, we know that from the basic thermodynamics and also from the previous chapters. Cycle means it has initial and final states must be same. So here I will start with the water as a media, right? So first of all, here water will be cold, water will be there. This is called there are four parts. One is boiler, turbine, condenser and pump. So this is generator. So whatever notations I have written here. B is for boiler, E is for turbine, T is for pump, C is for condenser, CW is for cold water and HW for hot water. So what are the rules of each one? Already you know what is the function of turbine. Turbine is a mechanical device which converts rotary motion into electrical energy. It will be helpful for transmitting rotary motion of the some energy is converted into electrical energy. So boiler is a device which will convert cold water into whatever water input water into that will be converted into steam. Right. Pump is to pump the feed water into the boiler, and condenser is a device which will convert, which is the opposite of boiler. Here water is converted into steam, here this steam is converted into water. So this is here water to steam and here steam to water. Right. So all of you, I'll start with this. There is a pump which will pump the water and supply to the boiler, where you are adding heat in the boiler. That boiler is converting that water into steam. Steam is passed to turbine, and turbine the steam is going to expand to generate the energy, and then you are supplying to the condenser. So this is cycle is repeating. So how this condenser is taking care means converting steam into liquid. So hot this wet steam, it is in the terms of wet steam, means already it is in the superheated steam or dry steam. That steam, whenever it passes through this turbine phases, it is converted into wet steam, means steam which has some particles, but it is in the higher temperature. So here higher temperature is reduced to normal water. It is converted into normal water by a condenser which acts as a heat exchanger, where cold water enters and hot water goes out. Cold water enter means whenever this cold water enters, it will come in touch with this steam, and what is the nature of law? Higher temperature to lower temperature, heat is going to flow. So heat from the wet steam is going to go to the pass to this cold water, which is coming out as hot water. So whatever temperature of this steam is transferred to this water which is entering and it is going out, then this wet steam is again converted into water, pumped back to the boiler, and boiler is taking care of turbine. So this is how this cycle is going to work, right? But so as to analyze this, what is the efficiency, how it is going to generate, then we are going to look after two cycles. One is, there are two cycles which operate this energy generation. One is Carnot cycle, another one is Rankine cycle. Carnot cycle already I have said you, it is one of the theoretical cycle, and we'll do both and we'll consider which one is better, right? So now I'll go for Carnot cycle. Carnot Vapour power cycle. So just you know already the PV and TS diagram. Already whatever we have done in earlier phases, we have drawn PV and TS diagram. Here I will draw PV and HS diagram. HS is enthalpy. Enthalpy is function of temperature itself. So graph of HS itself is called as Molière chart, right? So now I just draw the PV diagram. One, two, three, four. What is TS diagram for Carnot cycle? It is a rectangle. Already we know that. So this S is constant and this is T is constant. Already we have studied in the first unit itself. So here, since these two processes are entropy is constant, so heat addition and heat rejection should happen in this two only. So here we are considering this as heat addition, that is heat supply, and here it is heat rejected. Right. So process 1 to 2, already we have seen this diagram. This is boiler, turbine, condenser, pump. 1, 2, 3, 4. We have seen this. So 1 to 2 is boiler work, 2 to 3 is condenser heat rejection, 3 to 4 is heat addition, pump work, 3 to 4 is heat addition but minor case, 4 to 1 is actually heat addition. This is also isentropic, this working of 1 to 2 and 3 to 4 is in the form of isentropic process, right? Now already I have sent you the PDF notes of this notes, whatever I am carrying here, it is already with you. Just look at the notes and see the videos. Right. So process 1 to 2, which what is going to happen? 1 to 2. It is case of turbine. So work is going to generate. So WT. What will be the this one? Work done H1 minus H2 kilojoules per kg, means enthalpy in terms of enthalpy. Process 2 to 3, which work? Condenser work. Isothermal work, here heat is rejected. Condenser means you should always think it is heat rejected. Boiler means you should think it is as heat added. Pump and turbine both are isentropic processes where no heat, no gain. So it is a adiabatic process. HR. So what will be the heat? Heat will be more at the exit of turbine, and it is in terms of wet steam. It is in terms of steam. Here it is water. So temperature of steam will be more than water. So it is obviously condenser QR and heat rejected. It is H2 minus H3. Same kilojoules per kg. Process 3 to 4. Again pump work. WP. What is the difference between turbine work and pump work is turbine is work generating and pump is work absorbing. Means we need work is given by this turbine and pump is taking the work from this one. So we need to supply the work to the pump, and we are getting work from the turbine. So WP is equal to H4 minus H3. So I can say whatever water is entering here, it is undergoing the pump in terms of blades. It is rotating and it's going out. Rotating means it is a turbulence where some heat is added to that. So temperature at 4 will be more than temperature at 3. So H4 minus H3. So fourth, process 4 to 1, boiler work. So this is condenser and this is boiler. So heat is added QS. So heat is added means we are burning fuels to generate that water into steam. So I can say this is H1 minus H4. So simple things are there, just concentrate upon this. Now we have all the equations. I'll try to derive the efficiency for this Carnot cycle. Now I am seeing only Carnot cycle. I am going to derive the efficiency. Just look here. First one, and the efficiency in terms of thermal efficiency in terms of enthalpy. Second one in terms of temperature. Efficiency, what is formula? We know that already, W net divided by heat supplied. So W net is work done by the turbine minus work done by the pump divided by heat supplied at the boiler. So H1 minus H2, this is turbine work, H4 minus H3 is pump work divided by H1 minus H4. So this one I can write like this: H1 minus H2 minus H4 plus H3 divided by H1 minus H4. So if I write like this, is there any problem? H1 minus H4 minus H2 minus H3 divided by H1 minus H4. So this and this will cancel and it will become 1. H2 minus H3 divided by H1 minus H4. So this is the efficiency of Rankine cycle for vapor power cycle in terms of enthalpy. In terms of temperature, again I can same formula. Same formula already we know that Hs minus Hr divided by Hs. So 1 minus Hr by Hs. 1 minus Hr. So T2 into S2 minus S3 divided by T1 minus S1 minus S4. So these both are equal. You can see the TS diagram. So I will get 1 minus T2 by T1. So in terms of temperature. So as I am saying enthalpy, what is enthalpy? It is a measurement of energy in thermodynamic system. Right. So we have some definitions, very important from the problems point of view. So this is how we have to derive the equation. Right. So we have some, this one you have already notes, just I will glance over this. Work ratio. Second one, SSC. Right. So these two are very important from problems point of view. Work ratio is nothing but net work to the turbine work. So net work to the turbine work. So what is net work? WT minus WP divided by WT. So this is 1 minus WP divided by WT. Right. So this is very clear. What is work ratio? The work done by the total work divided by the turbine work. So specific steam consumption. SSC is nothing but specific steam consumption. Nothing but it is also called as steam rate. Right. So what is definition? It is defined as flow rate of steam per unit of power developed. So ratio SSC is flow rate, steam flow rate. Please look at the notes which I have given already. Steam flow rate. Flow rate, if I say it is in terms of kg per hour. Per kg how much flow rate? What is definition of rate again? It is defined as flow rate of steam per unit power developed. Per unit power developed is net work in terms of kilowatt. So what is SSC? SSC is in terms of kg per kilowatt hour. So this is SSC. Right. So this is how we need to understand. Right. But whatever I said, we are talking about Carnot Vapour power cycle. We are talking about Carnot Vapour power cycle. It has two isothermal, two isentropic process. Isothermal and isentropic process practically which are not possible. We cannot maintain a isentropic process in this one condenser. In turbine. We cannot maintain isentropic process in pump. We cannot maintain constant temperature in the boiler or in the turbine. So which is impractical. So drawbacks of Carnot cycle already I have listed here. Theoretically, Carnot cycle gives the highest possible efficiency. Theoretically it may give, but practically it's not giving. However, the cycle is extremely difficult to operate practically when steam used as a working fluid. So we cannot use that as a practical reasons. It is difficult to supply superheated at a constant pressure. So whatever reasons are, superheated steam cannot be at a constant pressure, right? Quantity of steam decreases during isentropic expansion. We are seeing that in this cycle fluid is going to be same at the same quantity, but it is going to decrease during the isentropic expansion. Steam is partially condensed in the condenser. Partially condensed, wholly thing is not condensed, so that is also not possible. Working substance at condition 3 is both liquid and vapor state. It is difficult to compress two-phase mixture isentropically. Again, two-phase mixture, when I am saying what is the outlet of turbine is in the form of steam, exit of condenser in terms of liquid. So this combination of two phases is it's not usually possible. So isentropic compression of a vapor requires more work due to its high specific value, right? So this is we have studied. What all we have studied now? We have studied a general flow chart of a steam power plant. We have studied Rankine cycle PV and HS diagram. We have listed the processes. We have calculated the work done by the turbine, pump, heat rejected, heat supplied, and we have consolidated and found out the efficiency, thermal efficiency in terms of enthalpy and in terms of temperature also. Then we have gone for studying work ratio, that is net work divided by turbine work, and specific steam consumption, that is steam consumed in kg per hour divided by net work done, that is kg per kilowatt hour. And we have studied some of the drawbacks. Because of its processes, it is highly drawback one, right? Later in the next video, just I'll start with this one, Rankine cycle, and also I will derive the efficiency for the same. Then we will go for one by one this one steps.
बदलू आपण लास्ट